very delighted to see Therese make that slide showing Ron and Gaiman, because they really have been the pillars of the last 10 years. But then, standing at the back, I just talked to Belvin, Louis, and Charlie. Where is Charlie? Oh, Charlie's there now. And they were three of us were feeling a bit sad that it was the end of this program. So I wanted to give a talk today where I feel like we're looking to the future. Because I know for the Energy Commission, this new EPIC program is the future of the Energy Commission work. And for us at Berkeley, this new-ish program called the Berkeley Energy and Climate Institute is our way forward as we go into the next 2 decades of energy research at Berkeley. And I also would like to say that on behalf of Dick White at the front here, Dick, can you just put your hand up? As you know, Dick and Jim Evans, David Culler, Chris Piester, there's been many people involved in this program, and we also are continuing in the future. This BECI organization, the Berkeley Energy and Climate Institute, was founded about 3 years ago by the lab director, Paul Alivisatos, the chancellor of Berkeley, and then Graham Fleming, who is my immediate boss, in order to really bring all of these assets of the campus together. And our main focuses, our main 3 pillars, are in research, education, and business, and I'm going to talk about those today. Briefly, I wanted to introduce at the back there Tracy Turner, who's our Director of Operations, if you could put your hand up. Sean Waihira, who's our analyst. Going across the back there, Jennifer Granholm is one of our senior fellows. She's the former governor of Michigan and very heavily involved in our programs. And so we're seeing the future as well as the past today. The second slide that I wanted to show you then is that what makes BECI special is that we're especially focusing on the short-term, high-impact projects with these SWAT teams, and I'll show you some of those. Our education goes across the whole campus, and once again, we're doing high-impact programs that are different to normal college programs. And then through programs like the C2M program that some of you know, through the Skydeck of Berkeley, and through the Citrus Foundry, and through our own new incubator, we're doing business development for these energy issues. This is the acronym soup of Berkeley and Berkeley Lab. There's a huge, huge amount of assets at Berkeley and at Berkeley Labs. If I added up the amount of money that's being spent on energy and climate between the lab and the campus, it's well over $500 million a year in research funding. And our job in BECI is to really draw this from all around the campus and have a terrific asset meeting. Actually, somebody just came in, Rajat Gad, professor at UCLA. I wasn't quite on your thesis committee at Carnegie Mellon, but it was close, right? We were good. We were very close, right? So this, again, is very much like old home week, but at the same time, I'm now looking at the future. So this busiest slide really shows the first element of BECI is the R for research. Now, as you know, all around the campus, there's a huge amount of classical academic research that's being done. And I can say this as a professor, as Jim Evans says to Dick and myself, when we're pointy-headed professors, that's how Jim describes it, we're doing work that we, with our students, we publish it in journals. But as we all know, very rarely do those journals sort of access the public and make huge impacts very quickly. So BECI has been set up by the Philomathia Foundation and others to do this kind of high-impact work. Here's one example just at the top with Steve Weissman, who's the professor in law. We got this phone call out of the blue after Superstorm Sandy. This special committee in Washington with Congressman Waxman and Senator Whitehouse was saying, what can we do now? What can the president do to change climate, putting laws into practice, changing climate policy? And to my surprise anyway, Steve, who is an expert in this area, showed us that these government agencies like FERC, the Department of the Interior, and USDA, they already have many programs, many laws actually, on their federal regulations that can cause a lot of good things to happen around climate. And Steve's job was to produce these reports to really show how we could quickly make changes in climate law. And right now, those reports are circulating around the White House. They're being read on the congressional floor. And that kind of work can make a really big impact. Danny Cullenward, who's not here today, is doing related similar work to Steve for California. Another important project being led by Professor Granholm, who I just introduced you to, is a state-by-state analysis of where clean tech jobs are. And she's doing, with a big bunch of students, one of whom's here today, Amanda, I believe, that's right. They're analyzing the environment in the states, state by state, and showing where we can identify roadmaps and who's getting it right to accelerate the growth of jobs, especially in the clean tech industry. And my own work today, you're here with some of my students, like Richard and Richard, who are speaking, speaking later on. By the way, they're both postdocs now, really, rather than students, right? So we'll have to say that. I mean, he's a month away from being a... But in any event, they're going to be producing some of the work that's very impactful. Another person who just walked in, by the way, is Clark Blumstein. Without him, nothing would happen, so we should give him a small round of applause for that. I've got to embarrass you in public. Why the hell are you late? We've all been waiting for you. The other thing that's happening in education is just absolutely wonderful. And again, embarrassing Tracy in public. She has just run, I mean, I say she has just run this program called the Cal Energy Corps. It's loosely modeled on the Peace Corps. So these 25 students have a life-changing event each year. It costs the university about $10,000 a student, and I have to fix that. And what we're doing is sending them to various places around the world, including the US, and fundamentally changing their lives. I mean, one of these guys called Leo Kosteski, it's a funny little story. He was undeclared, had no idea what he was going to do with his future. He went to Africa and started an organization where, quite literally, they're turning poop into energy, right? They're doing that kind of biofuel work. And when he came back, he came to my office. He said, look, Professor Wright, I can't stand it. I'm not an engineer. You've got to get me into engineering somehow. And I was able to pull a few strings, talk to the dean's office here, and we got him back into civil engineering. And now it changed his life. He's now going to go and be a startup company leader. And that experience really made someone's life change. Similarly, in education, we have this wonderful organization of about 2,000 students now, very large alumni group. And they have this annual summit, they have many meetings, and that's a very passionate group for energy and climate that are really changing things, so they're very influential on campus. And so these two organizations, hosted by BECI, are different to classical education. These are high-impact, very passionate people. The third area, there's that C2M program on campus, which is fantastic, and I need to put them on this slide. But we also spent some money recently changing our Echeverry labs into a wet lab incubator, which is shown here. Here's Rich Winslow in the front here. Who's that? Is that Martin? I can't quite see. In any event, we've been doing some very cool things in that. This lab actually was the birthplace of Imprint Energy. And that's one of the things we boast about a lot in our program, because Christine Ho, who was one of our graduates, teamed up with an MBA program in the C2M area, and she and Brooks Kincaid now have a vibrant battery company down in Alameda. They only have about 12 people there, but they're expanding all the time. They just got some Series A funding, about $6 million, and their little batteries, about as big as a postage stamp, are being used now by Nike in development areas for wearable computing. Those batteries could also be put on food consignments to track foods across the country. And so this idea of these small batteries is very important. And we're getting to the point now where these are bendable. They can be put onto flexographic surfaces. And also they're charged by ambient heat. Marco at the back there, Marco, you put your hand up. Marco Salvioli, who's one of our international students from Italy. And Zach Giemer here, put your hand up, another one of our great students. They're working on the idea of charging these batteries from the ambient heat that's around. And as I mentioned here, Imprint Energy is that company that we formed from this program, and that's why Therese wanted to put that in the program. Okay, so we're doing great. This organization called BECI, I'm excited to be the director of it. I was the citrus director before, and now this feels like citrus on steroids to me, but with a very important mission. where the world still has a long way to go. Even though we're in this meeting place today, and as Californians, most of us, feeling very proud of what happens in California, things are not great in the outside world. For example, every year, many of you, I'm sure, get this BP statistical review of world energy. And this is June 2014. It's brand new stuff. And I took this slide with Dan Chapman's help from page 42. Those of you in the back of the room, Tracy, Jennifer, Marco, I'm not sure if you have your glasses on, but can you even see? Can you even see the renewable slice? It's pathetic. Right? That orange slice there is how much the world is getting from renewables. So what do we have? We have oil. We have natural gas, which is better than a little bit better. The coal wedge is growing slightly. Hydro and nuclear, well, they're there, right, but they're not changing, and understandably so, because hydro takes a lot of money to create a hydro dam, and we've had these challenges with nuclear. So in the end, even though this tiny piece of orange is growing just a little bit, we get a completely false view of the world by living in California. Now, it's nice to be a Californian. It's nice to be a rebel in California. Ron always wanted to be that way. And we're going to continue to be rebels, but we get a very false sense of how good things are. Here we are in California. We're beating our chests like this sort of big gorilla around the watering hole that we're changing our renewable portfolio standard. And by 2020 and 2030, we're going to have more renewables here, more renewables there. But for Christ's sake, look at the rest of the world. And if we think about the global warming environment, it's really bad. Okay, this is the most technical slide in my little environment here. Why am I showing this slide? It's very busy. Jennifer teases me about showing this slide, but it's the sort of nerdy version of what we need to talk about. The x-axis here goes from 1950 to the year 2100, the end of this next 100 years. The y-axis is simply the amount of carbon that's in the atmosphere. This wiggly orange line here, this is real data from the Mauna Loa 1960. This is that clean mountaintop in Hawaii that's actually measuring data. This line, as you can see, over just a short period of time, has gone very intensely from around 300 or so. Actually, back here in the British growth period and the American growth period, it was more like 280. And now, very recently, it just hit 400. That was last March, it hit 400. I took the NASA website data, and so this blue line is something that we just purely extrapolated in our research group. And what you see is that if this continues in this business of usual way, we're going to start hitting 800 and 1,000 easily, even if it just goes on that simple projection. And this is not thinking about glaciers that might collapse. It's not thinking about the methane in the Russian permafrost. This is just a simple extraction. And this is all because our current system is based on fossil fuel economy. We need, as a group, to transition to this new fuel economy, as I say. We know the economy of the world is going to grow, and we need to do it with fuels that are carbon-free. What we need then is this sort of rebellious view of the world, and you're wondering why I'm looking at this slide here. We need to be these rebels in California, and we need to make that rebel situation go to the rest of the world with our research, with our education, with our business. And we've all become energy leaders in this room. So I'm beginning to use this phrase of rebels for a cause, rebels with a cause. I know it's going to be an uphill battle. You just saw this data. This data is really frightening. Something came in the mail to me the other day that really pissed me off. I might as well say that in public. I met this man. He's a very, very nice man, the CEO of Peabody Coal. I have his letter in here somewhere. Very nice gentleman, passionate about coal. And this says, let's brighten the many faces of global energy poverty. Now, you know they hired a marketing firm to do that and spent a lot of money on it. But it's true in a way, right? All these people are shown in these photographs and throughout here don't have enough energy. The rest of the world needs a lot of energy. You can't stop politicians and ordinary people, ordinary consumers, wanting energy to make their lives better. So are we going to get it with coal, which is what we're mostly getting today, or are we going to try and get it with some renewables? We have to do it with renewables. Otherwise, as shown in that last slide, we are truly screwed. If we keep doing it with this, we're going to have this curve. We can't do this. We can't do this for the sake of our children. We have to keep growing the orange slice of that BP curve. Otherwise, things are going to get much worse. I don't think the elections that we had recently are going to help us much either, because now the Alaska governor is now going to be chair of the Senate, and that's going to make it worse. So California rebels really have to do this. And you're probably wondering why I'm showing this video of my daughter, which doesn't seem to be coming up anyway. How do I make the video run? Just click it? Oh. No, I just did.
The left button, left click button.
Left click button on a machine, I don't know how to work. Okay, I don't know why this is sideways. It wasn't when I sent it to you, but it was even more rebellious.
She's Spider-Woman.
Okay, now look at this. See what happened then? That's why I wanted to show you this video of my daughter. First of all, by the time she gets to the age that I'm at, she's going to be way up that curve. So I'm very inspired to make her life better. The thing I wanted to show you, though, is she's dancing all happily for a while, and she falls over, and what happened? The minute she got up, she's still dancing and laughing and smiling. And we have to be that way. We have to keep going to change this into this with a much better orange slice, and we have to do it by being very rebellious, which we're doing in California, but we have to do more of that with our research, education, and business. So thank you for being here. I over-talked my time a bit, but I really enjoyed talking about it, and I look forward to the rest of the day and the wonderful presentations that we're going to get. Therese, over to you. Thank you.
Back to you. Okay, Paul, I think you're on next. You'll be introducing
Oh, I'm on again.
Rich and Richard.
Jeez. All right, so I'm sorry I'm on twice. You can leave if you need to.
1 minute, Paul.
These two folks, Rich Winslow and Richard Hsu, I'm delighted to say are two of the nicest and most intelligent people I've ever met. They are going to talk about one of our contracts, which was specifically focused on business development. And one of them is around the next generation of printable batteries and being self-charged by the thermoelectric generator. And the other one is around stick-on sensors for residential energy monitoring. The places where these two companies can focus are this. You can't really see it so well, but on the top there is a tiny sensor that we've been building that measures the condition of this pump, which is in the basement of this building. Domenico, who is the building manager, has helped us to make this project go. So this is a new version of Imprint Energy, the company we created already, where now Imprint Energy batteries will be able to be self-powered from the minor vibrations that come from this pump, and then we'll be able to do the analysis on the quality of the pump. Richard's project has already begun a company called Persistent Efficiency, and that is using stick-on sensors in commercial buildings, and I'll get to that in a second. The printed devices are continuing to be made in our lab. This is the work that was started by Dan Steingart, who's now a professor at Princeton. And then Christine, as I said just a few minutes ago, teamed up with Brooks Kincaid, and they created this company called Imprint Energy. The university has a shared patent situation with that company, and so the funding that came from the Energy Commission is flowing back to the state. And as that company grows, we can expect that it will go into new areas, such as the thermoelectric generation to power those batteries and the thermoelectric generation to power those batteries. Richard's work is interesting, which he will talk about, with his stick-on sub-metering work. And this is something that Dick White in the front, again, who I introduced before, has been one of the major players within. And Richard, I do believe this is a photograph of your circuit breaker panel at home. Is that correct?
No, this is not.
It's not.
We have a lot of breakers.
Oh, we have a lot of breakers. Okay. This one, I don't know where this is from. It just said, the reason I thought it wasn't our lab is it says kitchen and heater here and so on. So here's a classical circuit breaker panel. He has placed his sensors on those locations. And with Dick and some undergraduate students, they use these GMR sensors to measure the current in the circuit breaker panels and then track how much energy is being used in someone's house. As a result, we now have this design tool which also can look at the left-hand side of this to show how much power is being drawn by the radios on the sensors on one side and the microcontroller that's making the system work. And then on the top here, in this case using thermoelectric generators, we're able to power an onboard battery and also able to power an onboard capacitor to run the kind of systems that you just saw there. This is being done in the new lab that we created with money from the university and from the, a little bit from the dean's office, where the students are working in this lab and generating these energy harvesting systems for 3D printing of batteries and integrating it with software platforms for building science. So I'm going to just briefly then stop at that point, just to tee up the two guys and emphasize that the work that led to the company Imprint Energy from this project is now expanding so that Imprint Energy's batteries can be self-powered, and we probably will start a new company around that as we go forward. Richard and Jason Traeger have already started this company called Persistent Efficiency. The commercial building in Chicago is being monitored using that technology, and that company we hope will grow and prosper and be a real extra legacy of what's happening from the ETD project. So without further ado, Therese, let's introduce our first one of the young speakers, and Richard will now tell you more about the Persistent Efficiency Company.